313 reads, the following data table is taken from the study reported in exercise 312. Here, stressed means that the person reported that most days are extremely stressful or quite stressful, and not stressed means that the person reported that most days are a bit stressful, not stressful, or not at all stressful. And it gives us the table right here. What is the probability, part A asks, what is the probability that someone in this study is stressed? So what is the probability that someone is stressed? So in this case, we don't care if the person makes low income, medium income, or high income, but just whether they're stressed or not. So out of the 6,549 people who were in the study, 1,016 were stressed. So this is going to be 1016 divided by 6549, and that is equal to 0.155. B asks, what is the probability that someone in this study has low income? So I'm just going to write probability of low. And so again, we don't care if they're stressed or not stressed, we just care about everybody who has low income. So in this case, 2480 divided by 6549. And that is equal to 0.379. That's the probability of having low income. C asks, what is the probability that someone in this study either is stressed or has low income or both? So we want to know those who are either stressed, okay, so that includes these people, or has low income, or both. So in that case, we're interested in this group of people, which is both stressed and low income. These are low income but not stressed, and these are stressed, medium income, and stressed high income. Okay, so in that case, probability of low income or stress, okay, implying or both, and that's going to be, we can just add these numbers up, 526 plus 274 plus 216 plus 1954 divided by every single person in the study, and that's equal to 526 2970 divided by 6549, which is equal to 0.454. Okay? Now, we also know that this can be rewritten as the probability of low union stress, okay, which in this case is the probability of having low income plus the probability of being stressed minus the probability of being both. The intersection there, stress, okay? I'm still doing the exact same problem, and I'm just doing it in another way. So in this case, what we're doing is we're adding up everybody who has low income, which in this case is this column here, okay? So it includes these two numbers for a total of 2480 plus this entire row here, okay, which totals out to 1016, okay? However, by doing this column and this column, we've double counted this group, so we have to subtract off the group we double counted. We just subtracted off once because we still want to count that group, but we just don't want to count it twice. Okay, and if you do the math here, 2480 plus 1016 minus 526, it equals the exact same number, 2970. The top is exactly the same in both cases, and we will still have 0.454 as our answer. Okay, I'm going to have to erase a little bit in order to do part D, but you can see that we can find the same answer by either adding up the individual components, or kind of taking the shortcut by adding across the row and the column and subtracting the overlapping area. Okay. Now I've drawn all over the table there. And finally, what is the probability that someone in this study either is stressed and, what is the probability that someone in this study either is stressed and has low income? I think that either is in there incorrectly, so it's just what is the probability that someone is stressed and has low income. So in this case, we're interested only in those who are stressed and have low income. So in that case, it's going to be 0.526 out of 6549. And that is equal to 0.080.